Differentiation versus integration. Which one is more challenging? To find out the answer to this question, we'll be doing one question on differentiation and one question on integration, and we'll be rating each question on a scale from 1 to 10 in difficulty, and the question with the highest score wins. Now let's get right into it. The first question we have is about differentiation. The curve C has an equation y equals x plus 1 times x plus 3 squared. Part A states sketch C showing the coordinates of the points at which C meets the axes. Now, before we answer any questions, we must first expand out the equation C. So that is y is equal to x plus 1, x plus 3, x plus 3. So we're going to do x plus 3 squared first. So that would be x plus 1 here. And then x times x is x squared. Plus 3x would be plus 6x. 3 times 3, which is equal to 9. And then when we expand this one out, this would give us x cubed plus 7x squared plus 15x plus 9. This is the full expanded out version of curve C, but that's the fully expanded equation. Now, when we sketch C, we know that the shape is going to be a cubic graph since we have a cubic equation. And the points at which C meets the axes would be -3, 0 and -1, 0. As we have x plus 1 and x plus 3 as two brackets here. And when you substitute in -1 into the x plus 1 bracket and -3 to the x plus 3 bracket, these both give out 0. Now let's sketch C. So let's draw axes here. That's your x, and that's your y. This would be our origin here. Let's assume that this is -1, this is -3. We bring it in, it crosses through both, and it would keep increasing. So that's a point, that's a point. Then we write down -3, 0, and -1, 0. Now we've solved question A. Question B says, show that dy over dx is equal to 3x squared plus 14x plus 15. To simply answer this question, we just have to differentiate the equation of curve C. Now let's do that. So we write down dy over dx. So the derivative of x cubed would be, you do 1 times 3, because that's the coefficient. So that would be 3x minus 1 from the power, that's squared, 3x squared. Then we do 7 times 2, which is 14x. Take away the power, so that just stays 1. And 15x would just be plus 15. We've solved question B as well. Now question C states, the point A has an x coordinate of -5 and this lies on C. We have to find the equation of tangent to C at A, giving your answer in the form y is equal to mx plus c, where the m and the c are constants. When we find the equation of the tangent, we know that dy over dx is the gradient, resembles the gradient at any given point in a curve. Therefore, when we work out the gradient at the point -5, this would be the gradient of the normal. But to change it to the gradient of the tangent, we just have to do the negative reciprocal of the normal gradient. So let's do that right now. Part C. So we got to sub in -5 into the dy over dx. So that'd be 3 bracket -5 squared plus 14 times -5 plus 15. Now this, So 3 bracket minus 5 bracket squared, that's going to equal 25 times 3, which is 75. 75 minus 70, which is from the 14 times minus 5. That's going to equal to 5. 5 plus 15 is equal to 20. So that's the value of dy of dx, so, or the gradient of the normal. But the gradient of the tangent, so let's for example, the gradient is m of tangent is going to equal minus 1 over 20. So that would be our answer here. And then next, we have to work out what the y value is. So we just have to sub in minus 5, which is the x coordinate, into the equation of curve C. So y is equal to minus, so it'd be x, my bad, it would be minus 5 plus 1, and then we'd have minus 5 plus 3 squared, and this would equal to minus 5 plus 1 is minus 4. Minus 4 times minus 5 plus 3 is equal to minus 2. Minus 2 squared is equal to 4, which would be minus 4 times 4, which would equal to minus 16. That is our y coordinate. So let's write the coordinate down right here. So it'd be 5 minus 16. Then we sub in the tangent, the x1 and the y1 into the equation y minus y1 equal to m bracket x minus x1. Now let's do that right now. That'd be y plus 16, because it'd be minus a 16. Two negatives make a positive, would equal to minus 1 over 20 bracket x minus 5, which would equal to y plus 16 is equal to minus 1 over 20 x plus, let's have a look, minus 1 over 20 times minus 5 minus plus 1 over 4. We simply have to bring the 16 to the other side so that it becomes y equals mx plus c. Therefore, y would equal to minus 1 over 20 x minus, because it's going to be negative since we do 1 over 4 minus 16, and this would equal to minus 63 over 4. Now overall, you can see how much space this question has taken up and how much complexity it has. So on a scale of 1 to 10 in terms of difficulty, I would say that this is a solid 8 out of 10 in difficulty. Now let's move on to the integration question. We are on to the next question. This is the question for integration. Now right here we have to work out the area under the curve of the following 3 points here. So as you can see here, the area under the curve between 0 and 2, that's positive. However, the area of the curve between 0 and 1 is negative. It is down in the negative axis. And then the area between 1 and 4, that's also going to be a positive value. Now, we first need to integrate the equation. However, the equation is not in its expanded form. So before we do anything, we must expand the equation out. So first, let's work out what the brackets are equal to. Then we can times by negative 1 over 4. So y is going to equal to, we'll do x plus 2 and x minus 1 first, which is going to equal to x squared plus 2x minus x minus 2, which is going to equal to x squared plus x minus 2. Then we're going to do the x squared plus x minus 2 times that by x minus 4. We have x cubed plus x squared minus 2x minus 4x squared minus 4x squared minus 4x plus 8. Now let's add all of these together. It's going to equal to x cubed minus 3x squared minus 6x plus 8. And we have to times this all by negative 1 over 4. And if we do that, minus 1 over 4 x cubed plus, let's have a look, 1 over 4 times 3 plus 3 over 4 x squared. And then we have 1 over 4 times 6 plus 3 over 2 x, and then 8 times minus 1 over 4, that's just equal to minus 2. Now this is a fully expanded form of the equation of y. All we gotta do is integrate this. So let's put brackets around them. And it would be dx rather than dy over dx. Now integration resembles the area under the curve and is the opposite of differentiation. Just wanted to let you know that. Now, all you have to do is integrate this. When we integrate, we have to add 1 to the power first. So we've got to do an equal here. It'd be x to the power of 4. And we do minus 1 over 4 divided by 4, which would be minus 1 over 16. Then we do a plus here. We do add 1 to the power, which would be x cubed. We do 3 over 4 divided by 3, which would be 3 over 12. You can also rewrite that as 1 over 4, but we'll ignore that for now. Then we do plus an x squared here, and so you'd be doing 3 over 2 divided by 2, which would be 3 over 4, and the minus 2, you just add an x, so it just becomes minus 2x. We can usually put the plus c on the end, but in this case, for the area under the curve, we don't need to include plus c. Now we know that what our dx is, we can now work out the area under the curve of each point. So let's work out the area between naught minus 2. So let's do that first. Dx, that's just a shorter way of writing this. So we know that 0 is going to give us no value, so there's no purpose in writing 0, because it's just going to equal to 0. So rather, we can just work out what minus 2 is when you substitute it into dx, and that would be our area under the curve. So do 4, and it'd be units squared. As there's no specific units, so it's best to write units squared. Now let's work out the area under the curve between 1 and 0. Again, we don't have to include 0 in, as 0 is going to give us no value, so you can just substitute 1 in and find out the area under the curve. Now in this case, since it's under the negative axis, we have to include a negative in here to cancel out the negative charge that comes out. Now let's work out the value. Value for this is minus 17 over 16. So we do minus 17 over 16, as area cannot be negative. Therefore, we can say that the area is plus 17 over 16 units squared. Now, the 1 dx. In this case, we have to include both values and subtract both of these. So let's work out what. So we know that when it's 1, we know that it would be minus here. It'd be minus 17 over 16. The reason we have to do minus 17 over 16 is because when you work at the area, when you substitute both these values in, we have to subtract them, and when you put in 1, you get minus 17 over 16. But this is going to get cancelled out by the charges anyway, so it wouldn't make a difference. So let's sub in 4. When we substitute in 4, we also get 4 units squared. So if we do 4 minus 17 over 16, this is going to give us 81 over 16 units squared. And when we do the total of all of these, so simply add up all 3 areas that we've worked out. So it would be 81 over 16 plus 17 over 16 plus 4. So the total area of the shaded region is equal to 81 over 8 units squared, which is also equal to 10.1 to 1 decimal place. That was quite a tough question there. To be honest, I would say on a scale from 1 to 10, that is a 10 out of 10. That required a lot of workings out, especially expanding out the equation. To be honest, in an A-level exam, you probably wouldn't see that much often. That'd probably be a very difficult question if it did come up on one of the A-level exams. But to declare the winner, I would say that integration is definitely much more challenging than differentiation. So thank you so much for watching, guys. If you enjoyed this video, please make sure you subscribe to the Math Genius sub channel and stay tuned for more videos. Thank you.